Sometimes the biggest stories about our planet's past come from the absolute smallest, most unassuming clues. We're not talking about giant, towering skeletons here, but something way more delicate. Thousands of tiny fossilized eggshell fragments that were dug up from the deserts of Utah. And these little bits and pieces, they're the key to a 100-million-year-old puzzle. So let's start piecing it together. So, when paleontologists were sifting through everything they found, they knew they had dinosaur eggs. That part was expected. But then they found this, something they called a funky find. And that one funky find was the first real clue that this ancient nesting ground was hiding a much, much bigger secret. And that really is the central question for us today, right? We're going to see how we can take this 100-million-year-old puzzle and, piece by piece, show how these tiny fragments are completely changing what we thought we knew about the age of dinosaurs. Okay, so to get started, we have to go back in time, way back. Picture this, central Utah about 100 million years ago, deep in the Cretaceous period. But this isn't the desert we know today. Oh no, it was a lush, watery landscape full of forests and rivers, sitting right on the edge of this massive inland sea called the Western Interior Seaway. I mean, it was the perfect place for dinosaurs to lay their eggs. And lay eggs they definitely did. Across 20 different sites, researchers painstakingly collected over 4,000 of these tiny fragments. For a long time, the working theory was pretty simple. All these little bits and pieces probably came from just one type of dinosaur that really, really liked this neighborhood. I mean, it seemed logical, right? But as they were about to find out, it was totally wrong. So, back in the lab, after a whole lot of careful analysis, that simple picture just got shattered. What they actually found revealed a far more crowded, way more complex ancient world than anyone had ever imagined. This is the number that changed everything. Not one, but 6. The fragments belonged to 6 completely distinct types of eggs. This wasn't one dinosaur's private nesting area. It was more like a bustling shared maternity ward for a whole bunch of different animals. And the variety was just staggering. They found eggs from 3 different kinds of oviraptorosaurs, the feathered bird-like dinosaurs. Then there were eggs from 2 types of ornithopods, those classic plant-eating duck-billed dinos. And finally, there it was, that funky find, the eggshells of a crocodilomorph, a prehistoric crocodile cousin that nobody, and I mean nobody, expected to find nesting there. So here's why this is such a huge deal. This discovery completely flips the old script. The traditional view of these ecosystems was often a bit simplified, kind of a one-of-each model. One big predator, one big herbivore, and so on. But this new reality, it points to something that looks a lot more like a modern ecosystem, where you have multiple similar species all living side by side, competing for and sharing the same resources. But you might be wondering, how can scientists possibly know all of this from what, let's be honest, looks like a bunch of broken gravel? Well, this is where the real detective work kicks in, because fossilized eggshells are like these tiny, incredibly durable storybooks. You just have to know how to read them. First, here's a key term for you, ootaxa. It's basically a fancy way of giving a species name to a type of fossil egg. See, it's incredibly rare to find a little embryo still inside, so scientists classify the eggs themselves based on their unique features. Each ootaxon represents a different animal that laid those eggs. And the process itself is meticulous. After they're collected, the fragments go under a scanning electron microscope. This thing reveals these incredible, intricate crystal structures, patterns thinner than a human hair that are totally unique to each egg type. Then comes the geochemical analysis. They study the tiny pores in the shells, which can tell them about humidity and even how the nest was built. And get this, isotopes locked inside the shell can even reveal clues about the mother's diet and the climate she lived in. It's amazing. So with all that incredible forensic evidence, paleontologists can go from having just a pile of fragments to actually reconstructing an entire ancient environment and even the behaviors of the animals that lived there. This quote from Dr. Josh Hedge just nails it perfectly. We should stop thinking of dinosaur ecosystems as these simple, empty landscapes. Instead, we need to start picturing something more like the modern Serengeti, with different species of predators and herbivores all interacting in this complex, beautiful web of life. So, how did they all manage to get along without driving each other crazy? Well, the analysis of those tiny shell pores gives us the answer. They all had different nesting strategies. The crocodilomorphs, they probably buried their eggs in shallow mounds. The oviraptorosaurs created these open rings plastered with sand. And the ornithopods likely dug pits and covered their eggs with leaves. They weren't fighting for the best spots, they were just using the environment in different ways. It's a classic example of what we call resource partitioning. Now, this discovery in Utah isn't just some isolated story. It's a really important piece in a much larger puzzle that paleontologists are putting together about the social lives of dinosaurs, a story that stretches across tens of millions of years.
Right, so the Utah site gives us powerful evidence for coexistence. Different species sharing a nesting ground. That's cool. But other fossil sites have revealed something even more sophisticated. Clear evidence that some dinosaurs lived and moved in complex social herds.
And looking at this timeline really puts it all into perspective. The Utah find is from about 100 million years ago. But this other incredible discovery in Patagonia, it pushed the timeline for complex social behavior all the way back to 193 million years ago, in the early Jurassic. We're talking about a 93 million year gap. Yeah, this site in Patagonia was a total game changer. Researchers found a mass graveyard of a species called Musaurus. But the fossils weren't just scattered randomly. They were clustered by age. You had a communal nesting ground in one spot, a kind of school of young juveniles in another, and the adults were found nearby. This age segregation is the smoking gun for complex herding behavior. It shows that these animals organized themselves socially, and it proved it was happening 40 million years earlier than we had any direct proof for before. Which brings us right back to where we started. From tiny, unassuming eggshell fragments, we can reconstruct entire ecosystems and uncover social behaviors that span geological ages. It just proves that even the smallest clues can hold the biggest secrets. And it leaves us with a really fascinating question. What else is out there, buried right beneath our feet, just waiting to rewrite the story of our planet?